Hello children. Now let us continue with the complex numbers. So in last class we had done till question number 1. So now let us start question number 2. So question number 2, find the conjugate of each. So here the first one is 2 plus 3i. So clearly it's a complex number because it is in the form of a plus ib. So I am denoting this complex number as z is equal to 2 plus 3i. Now I need conjugate of this. Okay, so you know that if you have a complex number a plus ib, then conjugate of this will be z bar equal to a minus ib. That means whatever sign you have over here for that complex, for conjugate this sign would get changed. So here z is equal to 2 plus 3i, so conjugate will be z bar is equal to 2 minus 3i. Clear? This I have left as homework for you. Next, question number 3. It is 3 into square root of minus 2 into square root of 5. Here if you see, this is not in the form of a plus ib. Okay, though it's a complex number, we can make out because here is square root of minus 2. Okay, so this is not in the form of a plus ib. So first you need to simplify it. You got to write this in the form of a plus ib. So this 3 into square root of minus 2 can be written in 3 into square root of 2 into square root of minus 1 minus 2 into square root of 5. So you know that square root of minus 1 is nothing but I. So in the next step I can write this 3 into square root of 2 into I. So here I am writing it because the I part we always write on the right. Yes, and then minus 2 into square root of 5 here. Okay, so clearly you can see that now this is in the form of a plus ib. So let us denote this by z. So here I've got a complex number z is equal to minus 2 into square root of 5 plus 3 into square root of 2 into I. Now I need conjugate of this. So z bar is equal to, here this plus will become minus. So minus 2 into square root of 5 minus 3 into square root of 2 into I. Okay, so this is how we find the conjugate. Okay, so here you saw in the first the complex number was in the form a plus ib, so easily you could write the conjugate. Here it was not in that form, so first you got to write that in the form of a plus ib, then you find the conjugate. Okay, this 4 is left as homework for you. It's same as question number 3. Okay, try by yourself. Next is question number 5. Here it is 1 upon 1 minus I whole square. This is also not in the form of a plus ib. So you got to simplify. Here in the denominator you see I. Okay, so you got to remove this I from the denominator. So what you do, first let's expand it by the a minus b whole square formula. So by a minus b whole square formula you get this 1 square minus 2 times I plus I square. Okay, then equal to, this becomes 1 minus 2i, and this I square becomes minus 1 because I square is minus 1. Okay, so here 1 and this minus 1, these two are cancelled, then you are left with 1 upon minus 2i. Okay, in denominator still you have got I, that I has to be removed by rationalizing it. So what I do is I multiply and divide by I. Okay, so doing so, that would help you to get I square in the denominator. Okay, and you know I square is nothing but minus 1, so you get minus I upon minus 2, minus and minus cancel, becomes plus, then you are left with I upon 2. Okay, so now this I upon 2 is a complex number, and you can see this can be written in the form of a plus ib, because z is equal to I upon 2 means 0 plus I by 2. Okay, here a is 0 and your b is plus half. Okay, so you got the complex number z is equal to 0 plus I upon 2. Now write down the conjugate. So conjugate means z bar is equal to, this plus will become minus, so you get minus I upon 2. Okay, now next is find the complex roots of the equations. Here you can see these equations are there. Okay, these equations are there, and you have to find the value of x which will satisfy this equation. Okay, so first one, x square plus 4 is equal to 0. When I take this 4, that side becomes minus 4. Then I need the value of x, that means I should take the square root both the sides, so I'm left with x equal to plus minus square root of minus 4. Okay, so you know that whenever you're taking a square root, then you have to write plus minus, so that's why plus minus and this square root symbol and minus 4. Now this minus square root minus 4 means we can write square root of 4 into a square root of minus 1. Okay, so square root of 4, you know, it's 2, and square root of minus 1, you know, it's I. Okay, so you get x equal to plus minus 2i. So this is the complex root for this equation. Okay, because this is either 2i or minus 2i will satisfy this equation. Okay, now this I have left as a homework for you. X to the power 4 minus 16 is equal to 0. Try this by yourself. Here as a hint I can give that this x to the power 4 minus 16 can be written as x square whole square minus 4 whole square equal to 0. Then use the formula a square minus b square is equal to a minus b into a plus b. Anyway, you try by yourself. Okay, so and next 3. So here it is a quadratic equation. You can see it is in the form of ax square plus bx plus c is equal to 0. Here in place of a you have 1, in place of b you have 1, in place of c you have 1. So this is a quadratic equation. So in class 10 you all have been taught that formula, x equal to minus b plus minus square root of b square minus 4ac upon 2a. Okay, so for this we would use that formula. So here this is a quadratic equation, and we know the formula x equal to minus b plus minus under root b square minus 4ac by 2a. So simply substitute the values of a, b, c. Okay, so here in place of b we have 1, in place of a we have 1, in place of c also we have 1. So it becomes minus 1 plus minus square root of 1 square minus 4 into 1 upon 2 into 1. So you get minus 1 plus minus square root of 1 minus 4 upon 2. Now simplify it, so you get minus 1 plus minus square root of minus 3 upon 2. In next step, minus 1 plus minus square root of 3 into square root of minus 1. So we don't know exactly what will be the value of this. Okay, it will be in the decimal, so leave it as square root of 3 only, and square root of minus 1 means I. So in place of square root of minus 1 we will write I. So here we got the complex root for this equation. Okay, and now next, before we proceed on to the next question, here we have got something. Okay, now so next topic is amplitude or argument. Okay, amplitude or argument of a complex number. So suppose we have a complex number z is equal to a plus ib. So we have a complex number z is equal to a plus ib, and we want to find amplitude, okay, of this complex number. We also call it by argument. Okay, so either you say amplitude of z or argument of z, both implies same. So this is a complex number, and suppose I want amplitude of this complex number. So you write it as this: arg, z means argument of complex number z, or amp, that means amplitude of complex number z. So this is how we denote, okay, the amplitude or the argument, and the value is given as this: argument of z or amplitude of z is equal to tan inverse, here tan to the power minus 1. Okay, this doesn't mean 1 upon tan. Okay, so it is read as tan inverse b upon a, read as tan inverse b by a. So if you have a complex number z is equal to a plus ib, and you have been asked to find the argument of that complex number, so what you have to do is you have to find this value, tan inverse b upon a. Okay, b is here, a is here. So first of all, if the complex number is given in this form, so it's very easy, just substitute the values. And if it is not given in a plus ib form, so firstly you got to work on it and get into this form and then apply this formula. Okay, so whenever you have been asked for the amplitude or argument, it means tan inverse b upon a. Okay, so let us see question number 4. Find the modulus and the amplitude of each of the following complex number. So here number 1 is 1 plus I. Clearly this is in the form of a plus ib. Here your a is 1 and your b is also 1. Okay, so I'm denoting this complex number z is equal to 1 plus I. Okay, now we firstly will find the modulus. Okay, and modulus is given as this. This was explained in the previous class. Okay, so you can check your note where you have written the modulus of a complex number. So here z is equal to 1 plus I, so modulus will be denoted as this, and the value is given as a square plus b square. Here I have written it also. Suppose we have a complex number z is equal to a plus ib, then modulus will be this, square root of a square plus b square. So here I have got z is equal to 1 plus I, so a is 1 and b is also 1, so modulus will be square root of 1 square plus 1 square, that is equal to square root of 2. So modulus of this complex number is square root of 2. Next we will find the amplitude. Okay, so amplitude, just now we have seen that if you have a complex number a plus ib, then amplitude will be tan inverse b upon a. So here clearly it is in the form a plus ib, so here a is 1 and b is 1, so argument or amplitude z will be tan inverse b upon a, that is equal to tan inverse 1 upon 1, because b is also 1, a is also 1, so I got tan inverse 1. Now we have got a separate chapter for this inverse function, and that we will deal in class 12. So right now you have to just see as this. Suppose here I got tan inverse 1, so you have to tell me the angle, you have to tell me the angle for which tan gives you 1. Okay, you have to tell me the angle for which tan gives you 1. So you know that tan 45 is 1. Okay, so answer will be 45 degree, but here we will not write the angle in terms of degree, we will write in terms of radian. So it is pi by 4. Okay, so here I have written for you, you should learn this. Okay, you should remember this. 180 degree in radian is denoted by pi. Okay, so 180 degree in radian is equal to pi, so 1 degree means pi by 180 radian. Okay, and from this one you can conclude that 0 degree means 0 radian, 30 degree means pi by 6 radian, 45 degree means pi by 4 radian, 60 degree means pi by 3 radian, 90 degree means pi by 2 radian. Okay, so here when we got this tan inverse 1, okay, so the next step is to write the angle. Okay, the next step is to write the angle for which tan gives 1. Okay, so we know that tan 45 is 1. Okay, but we have to write in radian, not in degrees. So we know that 45 degree means pi by 4, so that's why pi by 4. Clear? Now let's see the next. Here next one is 1 minus I. Here this is also in the form of a plus ib. Yes, where your a is 1 and your b is minus 1. Okay, so here a is 1 and your b is minus 1, and so let us denote this complex by z. So z is equal to 1 minus I. Okay, So firstly we'll find the modulus, and you know that modulus will be given as square root of a squared plus b squared. So here a is 1 and b is -1, so put the values, you get square root of 2. Next, amplitude of this complex number z, so that would be equal to tan inverse b upon a, which is equal to -1, because your b is -1 upon a is 1, so -1 upon 1. Okay, so we get -1, so that minus sign comes out. Okay, so we are left with minus tan inverse 1. So just see this much, tan inverse 1. So you got to write the angle for which tan gives you 1. So you know that it's 45 degree, but you don't have to write in degree. In fact, you have to write radian. So that would be pi by 4, and this minus sign will be included with this. Next, this is your homework, -1 plus I. Okay, here you have to find the modulus and the amplitude. Next is 3 plus 4i. So this is also in terms in the form a plus ib. So I'm denoting z is equal to 3 plus 4i. Modulus is very easy, square root of a square plus b square, that means 3 square plus 4 square, you get square root of 25, that is 5. Now amplitude of z is equal to tan inverse b upon a, so tan inverse 4 by 3. But here till now you have no idea, okay, that for which angle tan gives you 4 by 3. So no need to proceed, okay, just leave it till here. Okay, now next is 5, 3 minus I into root 3. So again this is in the form a plus ib. So this is your homework. Try first find the modulus, that means you have to find square root of a square plus b square, and then you have to find the amplitude, that means tan inverse b upon a. Okay, try this. And this next here, 7th, here I've got 1 minus I upon 1 plus I. Clearly this is not in the form of a plus ib. It is not in the form of a plus ib. So first you got to simplify it and get this into a plus ib form. Okay, and for that, you know that in denominator we should not have any I, okay, anything in I term. Okay, so rationalize it. So after rationalizing it, okay, you will get minus I. Okay, that means this becomes 0 minus I. Okay, here you can see that we don't have a, that means a must be 0, so you can write 0 minus I. So here a is 0 and your b is -1. Okay, so z we get 0 minus I. So modulus will be square root of a square plus b square, so g square plus minus 1 whole square, that means you get square root of 1, that is equal to 1. So modulus is 1. Next, amplitude means tan inverse b upon a, that is equal to tan inverse -1 upon 0. So anything divided by 0 is not defined, so tan inverse not defined. Now if you remember the trigonometric table, okay, so for which angle tan gives you not defined, okay, so obviously that is the angle 90 degree. Okay, so that 90 in radian is written as pi by 2. So here you get pi by 2. Okay, and this question number 6 is your homework, same as 7. Okay, here firstly you got to write this in form of a plus ib. Okay, then proceed on same as this. Okay, this whatever we have done till now. So this is all for today. Okay, and please do the homework.